On this 2011-2025 Ford F250 Superduty with the 6.7 power stroke, P0299 generally points to a possible underboost condition. In plain terms, the engine controller may be seeing less boost than it expects. The truck may feel down on power, slow to accelerate, or go into a reduced power type behavior. Broadly, the fault area can be in the air path, charge air or intake plumbing, exhaust flow, turbo control, sensor inputs, wiring, connectors, or module command versus response logic. Treat it like a performance code. Start with the basic system checks before jumping to parts. Before getting deep into P0299, look for anything obvious that matches the customer concern. Check for related OASIS or bulletin information if it is available, and look closely at any previous repairs, because an incorrectly completed repair can contribute to the current problem. Then make sure the electrical foundation is solid. Check battery and charging system operation, and verify battery SOC is greater than 70% before beginning diagnostics. Check the network modules for system or symptom codes that help point you where to start. If other codes are present, check what they mean first. Circuit-related codes come before system or performance codes, and if several circuit codes are set, look for a shared power or ground issue. Next, inspect the truck without assuming the turbo is bad. Look over the harnesses for damage, chafing, and routing problems. Check fuses, circuits, and connectors for continuity and correct installation. On the mechanical side, make sure components are connected correctly. Then inspect the vacuum lines, air intake system, and hoses for leaks, damage, blockage, routing errors, or restrictions. Also check fuel quality and the fuel system for damage, leaks, and routing issues. Verify coolant level and quality with the engine operating at the correct temperature. Check oil level and quality, and inspect the exhaust system for damage, restrictions, and routing concerns. When you connect test equipment or jumper wires to pins, use Rotunda Flex probes, NUD 105R025F, or Terminal Probe Kit 418S035, so you do not damage terminals. Check male to female pin fit for a consistent, strong connection. Use the mating pin to feel normal separation force. A damaged pin will have very low separation force. If a small pin cannot be checked correctly because the connector hardshell, pin guide, or retainer is adding drag, remove the pin as needed for the fit check. Replace damaged connectors, pins, or terminals, and do not force test leads or probes into connectors, because that can create the next electrical fault. Use the scan tool to read PID inputs, output states, and diagnostic states. The data logger is useful here because it lets you watch detailed information without tearing the truck apart first. Make sure you understand how the module and system are supposed to work. Confirm programmable parameters are set correctly for the function in question. Resolve DTCs first, as directed by the diagnostic path. Then test hardwired and networked inputs. After that, test outputs and check for module software updates. If you use output state control, use it to confirm the module can switch an output on and off. If the output works normally, shift your attention back to the inputs instead of blaming the module. Unnecessary module replacement usually comes from incomplete testing. For a power-providing circuit carrying approximately 200 to 10,000 milliamps, load the circuit with a 250 to 350 milliamp test light and measure circuit voltage with a DMM while the test light is connected. As a guide for circuit size, conductor sizes 24 gauge, 0.5 millimeters, or smaller are generally used to carry approximately 1,000 milliamps, 1 ampere or less. If voltage drops during that load, suspect excessive resistance. For circuits carrying more than 1 ampere, load the circuit with a device that requires similar current, such as a brake light bulb. Conductor sizes 20 gauge, 0.8 millimeters, or larger are generally used to carry 1 ampere, 1,000 milliamps, or more. Use voltage drop as the preferred method on higher current circuits. For ground-providing circuits, measure voltage drop while the component is operating or while you are attempting to operate it. Use an ohm meter accurately only if the battery has been disconnected. For most small diameter, 18 gauge and smaller, wires, expect less than 2 ohms. For most wiring harness circuits, also expect less than 2 ohms. A standard DMM ohmmeter's low resistance resolution is approximately 0.1 ohm, so its accurate use is limited to circuits carrying less than approximately 5 amperes. When measuring resistance, reverse the DMM leads and watch for a change. Unless the circuit contains a semiconductor, reversing the leads should not change the reading. If it does, the test result is not valid. To check for unintended continuity to ground, disconnect both ends of the suspect circuit and measure between that circuit and ground. Expect resistance greater than 10,000 ohms. To check for unintended continuity to another unpowered circuit, disconnect both ends of both circuits and measure between them. Again, expect resistance greater than 10,000 ohms. To check for unintended continuity to a powered circuit, disconnect both ends of the suspect circuit, turn ignition, run power on, and measure voltage between the suspect circuit and ground. Expect no voltage. Use back probing only when the circuit has to be tested under actual operating conditions or when voltage drop has to be measured during operation. Back probing is risky because probe contact can be uncertain and terminals can be damaged. It's the wrong test for a single-point voltage check, where 0 volts may be a real result. And it's also the wrong test for checking continuity or opens with an ohm meter between 2 points. For voltage drop back probing, expect less than 5% of circuit operating voltage. A 0-volt result usually means the test conditions are wrong, current is not flowing, or the back probe connection is bad. If jumper wires are used for circuit analysis, always use fused jumper wires. The recommended universal testing jumper wire fuse is 5 amperes or less. Use a larger fuse rating only when the load requires it. Use flex probes or an equivalent method to prevent connector terminal damage. But remember, flex probes are not intended to carry high current greater than 5 amperes. Do not apply ground or power directly to module switched components with jumper wires unless the diagnostic path specifically calls for it. For voltage drop measurement, connect the voltmeter at the beginning and end of the suspect circuit, then operate or attempt to operate the circuit so power is available to flow. Follow conventional current flow with voltmeter polarity. A 0-volt reading points to bad voltmeter connections or a component that has not been turned on. A small amount of voltage is normal circuit loss, while voltage indications greater than 0.5 volts indicate abnormal voltage loss. For a voltage in, voltage out test, connect the negative lead to ground or the battery negative terminal. Operate the circuit and measure the power side and then the negative side of the load. The power side should be within 0.5 volts of battery voltage. The ground side should be greater than 0 volts but less than 0.5 volts. A reading of 0 volts or source voltage indicates an open circuit, and do not repair a circuit by overlaying a new wire in parallel until you understand what caused the original failure. Find and repair the root cause and inspect adjacent wiring damage. Keep verification separate from testing. The diagnostic assumes the concern is present when you test it. If the concern is not present, do not replace modules or other components just because a test path seems to point that way. After any correction, verify the repair and confirm the code stays gone under the same type of conditions that brought the concern in. If the P0299 specific branch is not defined, pause, recheck the earlier diagnostic path, and avoid guessing. The takeaway is simple. Prove the basics first, then use scan data, connector checks, circuit loading, and voltage drop testing to separate an air path or control problem from an electrical or module input problem. For more diagnostic training, visit stepdiagnostics.com.